Hello everyone, welcome to my channel. So in this video we are going to discuss the rest of the questions of Feb March 2019 paper 970912 pure mathematics 1. So that is 7th, 8th, 9th and 10th question. So without any delay, let's start with the 7th question. So here's the question number 7th, A part. Solve the equation 3 sine square 2 theta plus 8 cos 2 theta is equal to 0 and theta is from 0 to 180. So the angle is double angle, that is 2 theta. So we'll be finding the 2 theta in the beginning only. It is going to be from 0 to 360. It would be very helpful in finding the theta initially as the 2 theta, then we'll divide everywhere by 2 to get the original theta, and which will be in between the 0 and 180. So let's use the identity, first identity, to convert this sine square theta into cos square theta so that we can get a quadratic equation in cos, and hence it is 1 minus cos square 2 theta plus 8 times cos 2 theta is equal to 0. So if we'll simplify, it is going to be 3 minus 3 cos square 2 theta plus 8 cos 2 theta is equal to 0. So let's transfer everything to the other side so that I get this as a positive constant. So it is going to be 3 cos square 2 theta minus 8 cos 2 theta minus 3 is equal to 0. So we can see here it is 3 and minus 3, that is minus 9, and this coefficient is 8, minus 8. So we require two numbers by which we multiply, we get 9, and when we subtract we get 8, and we know that it is going to be 9 and 1, and since it is a quadratic in cos theta, so cos 2 theta, so it would be 3 cos square 2 theta minus 9 cos 2 theta and plus cos 2 theta minus 3 is equal to 0. So from first two terms we can take 3 cos 2 theta common, we will get cos 2 theta minus 3 plus from here these last two terms we can get 1 only, and hence it is cos 2 theta minus 3 is equal to 0. So now we can take cos 2 theta minus 3 common, and we will be left with 3 cos 2 theta plus 1 is equal to 0, and hence from here we will get cos 2 theta as 3, which is of course not possible because cos is from minus 1 to 1. The range of cos theta is always minus 1 to 1. So the possible value for cos 2 theta is going to be minus 1 over 3. So from calculator we will get 2 theta as cos inverse of minus 1 over 3, and in the degree it is equal to 109.471. So I'll write till 47. So this degree. Now we are not going to find theta yet because we will calculate any other possibility of for this 2 theta. We know that 2 theta vary between 0 and 360, and we are still having 109.47 degree. So for the next angle, we know for cos we have the next angle as 360 minus the previous angle. So 2 theta, another 2 theta will be 360 minus 109.47 degree, and which is 250.53, and hence next angle, for the next angle we know that next angle will be 360 plus this value, which is of course more than 360. So these are the two values, only possible values, and hence theta will be 109.47 upon 2 and 250.53 over 2, which is going to be 54.735. so it is 7 degree only because the answer we always give till one decimal place, and here it is 1 25.3 degree. So I hope it is clear. Let's do the next part of it. Part of 7th question. The diagram shows part of the graph y is equal to a plus tan bx, where x is measured in radians and a and b are constant. The curve intersects the x-axis at this point and the y-axis at this point. Find the values of a and b. So since this curve is passing through these 2 points, so it will satisfy these points, and hence at 0 comma root 3 we could have started with this also, but I'll start from here because I can see this is going to be 0, so I'll directly get the value of a. So it is root 3. I'm replacing the substituting the value of x and y. It is a plus tan b into 0, that is 0, and hence we know that tan 0 is equal to 0, so it is a is equal to root 3. This is the first value, one value, and now at minus 1 over 6 pi comma 0. So y is equal to 0. I'm substituting the value here. 0 is equal to a is root 3 plus tan minus pi over 6 and b is already there. So this I substitute the value of x here, and hence we can rewrite it as root 3 is equal root 3 and plus, and this is minus because tan, we know that tan of minus theta is equal to minus tan theta. So it would be minus tan pi over 6b. So it's together as an angle, and hence if we'll transfer it, we will get tan b pi over 6 is equal to root 3, and we know that root 3 is the value of tan pi by 3, and hence if we'll compare, we'll get b over 6 pi is equal to pi over 3, which will be cancelled, and we will get b is equal to 2. So I guess it is okay. Let's do the next question. Here is the 8th question. First part, express this in the form of x plus a whole square plus b. We can see it is the completing square method. So for the completing square method, we only require the coefficient of x. If it is 1, x square coefficient is 1, then we only require minus 4, and hence we can rewrite it as x square minus 4x plus 7 as x minus half of this 2 whole square and subtract the square of this number, that is minus 2 square plus 7. So we need to be very careful whether it is plus or minus. It does not harm this value. It will always be minus the square of this number. So it is going to be x minus 2 whole square minus 4 plus 7, and hence it is x minus 2 whole square plus 3. So this is the formula. This is expressed in this form, so we can see, we can relate a is minus 2 and b is equal to 3, which is not required to write. So it is the final answer. And the next part, the function f is defined by fx is equal to x square minus 4x plus 7, where for x less than k, where k is a constant. State the largest possible value for k for which f is decreasing function. So for decreasing function f dash x we need to find, and which is going to be 2x minus 4. So for decreasing function it should be less than 0, and hence we got 2x is less than 4 or x is less than 2. So now we can find out what is the maximum value, largest value of k. Largest value of k will be, we can write largest value of k is going to be 2. We can see it is the same thing, and hence now the second part, the value of k, they have given this fixed the value of k, which is now given to be 1. So if it is 1, find the expression for f inverse x. So we are going to write fx as, because we have written it already in the form of the first part, a minus b, a plus b whole square plus b. So it is going to be, I'm writing it as x minus 2 whole square plus 3. So if we need to find the inverse function, so we'll express in the form as y is equal to x minus 2 whole square for plus 3, and then interchange the x and y. That is going to be x is equal to y minus 2 whole square plus 3 or now let's make the y as a subject. So it is going to be x minus 3 is equal to minus y minus 2 whole square, and now we can take y minus 2 as plus minus root x minus 3. So now we have to decide whether we are going to take positive or negative. So if I'll write one more line, it is going to be 2 plus minus root x minus 3. So we know that fx is defined when x is less than 1. Fx is defined when x is less than 1. So this less than 1 will be it is a domain for fx. So x is less than 1 is going to be the range for the f inverse. So this is f inverse only. So it is f inverse. Now if we are going to take plus sign, positive sign here, it would be 2 minus some, and of course we know that it's x minus 3 is not going to be negative ever. So x minus 3, this will be positive. So 2 plus any positive number will always be more than 1, which is of course not acceptable, because the domain and range, domain of fx is equal to the range of f inverse x, and hence we have to take this as negative 1. So negative root x minus 3. So this is done, expression for f inverse x. Now state the domain. We only need to state the domain. So we know x is less than 1 and fx is x minus 2 whole square plus 3. So this is going to be the function like that, and this minimum value we are going to get at 2. It will be at 2. This point we know that it is going to be 2 comma 3. So this is the minimum point. So 1 will be somewhere here. So for that it is going to be the function like that. It is going up if you are talking about x less than 1. So we'll put only the value of x is equal to 1 to get the range. So f of 1 will be 1 minus 2 whole square, that is 1, plus 3. It will always be more than that. So domain of f inverse, we have found the range of it. Range is f of x will be always greater than 4, and hence this is going to be the domain of f inverse, and that is x is always greater than 4. I hope it is clear. Let's do the next part of it. So here's the fourth part. The function g is defined as g of x as 2 over x minus 1 for x greater than 1. Find an expression for gf of x and state the range of gf of x. So first of all, we'll write what are the things we have. First one is fx is given as x square minus 4x plus 7. Its domain is x is less than 1 and f of x is greater than 4. These are the things we have now. So let's find the expression for gf of x. So gf of x can be written as g of fx, which is 2 over fx minus 1. So fx, I'll write one more time, fx minus 1, which can be written as 2 over x square minus 4x plus 7 minus 1, or which can be written in this form, x square minus 4x plus 6. We can leave this till here also, or we can write in the completing square form in the denominator. It would be x minus 2 whole square, and it is minus 2 square, that is minus 4, plus 6, that is going to be plus 2. So this is the expression for gf of x. Now we have to decide for the range. We know it is going to be always positive. The denominator, numerator and denominator, both denominator is always going to be, both are going to be greater than 0. So first thing is gf of x is always going to be greater than 0. Now we have to decide for the upper bound, where it is going to be the next limit for the maximum value. So since we have f of x less than 0, greater than 4, so f of x minus 1, I'm going to take the help of this line. So f of x minus 1 will always be greater than 4 minus 1, that is 3, and hence 1 over f of x minus 1 will always be less than 1 over 3. We know that if we are taking the reciprocal, this inequality changes. So now it means 2 over f of x minus 1 will be less than 2 over 3, because just multiplying by 2, and hence this is the gx. So we got the range as gf of x will be greater than 0 and less than 2 by 3. I hope it is okay. Let's do the next question. So here's the question number 9. The diagram shows part of the curve with equation y is equal to square root of x cube plus x square. The shaded region is bounded by the curve, the x-axis, and the line x is equal to 3, which we can see here. So we need to find the volume obtained when the shaded region is rotated through 360-degree about x-axis. So about x-axis, the volume was, there is a fixed formula, we know it. Volume is from pi y square dx, from the starting limit of x to the end limit, that is 0 to 3. From here we can see, so y we have, so y is equal to square root of x cube plus x square, and hence the y square will be x cube plus x square only, because we are taking the square both the side, we can do that. And by putting it here, we'll get volume is equal to pi 0 to 3 x cube plus x square and dx. So now it is easy because we have x cube, which is simply x power 4 over 4, and plus x square integration is x cube over 3, and put the limit from 0 to 3. This is going to be pi and x as 3, so 3 power 4 is 81 over 4, plus x cube, that is 3 cube is 27 over 3, which is 9, and minus 0, so everywhere we'll get 0, so it is this only. So 81 over 4 plus 9 4 are 36, so it is going to be 36 plus 81 over 4 pi, which is 117 over 4 pi. So that is the value of the volume. As a unit cube we can write, we don't know the units, so we'll write only unit cube. Now let's do the second part of it. P is the point on the curve with x coordinate 3. Find the y coordinate of the point where the normal to the curve at P crosses the y-axis. So we know this is the graph, and suppose this is P, where x coordinate is 3, y coordinate we don't know, and at this point if we draw the tangent and then normal at this point, so where this is going to cross the y-axis, we require to get the y value of that. So first of all we'll find the y value, this y value, its tangent, and then the equation of normal, and then we'll see where this intersect with the y-axis, that is x is equal to 0. So at P, y is equal to square root of x cube plus x square, with x is 3, it is going to be x cube, 3 cube is 27, plus x square, that is 3 square, that is 9, and it is 27 plus 9 is 36, and hence it is going to be 6. And since it is a positive quadrant of y, so it would be 6, not plus minus 6. And of course we are going to take y is equal to root of this, so there is no minus anyway. So this point is, we can write the coordinates in this way, 3 comma 6. Now the gradient of the tangent is dy over dx at P. So y is square root of x cube plus x square, or we can write x cube plus x square whole to the power 1 by 2. So dy over dx will be 1 by 2 x cube plus x square to the power 1 by 2 minus 1, and then chain rule will, we have to do the differentiation of the bracket things. So it is going to be 3x square plus 2x. So gradient m, will write gradient m. So it is going to be at p, means at x is equal to 3, we'll get 1 over 2, and it is 3 cube 27 plus 9, 3 square 9, and minus 1 by 2 multiplied by 3x square. So 3 into 3 square, 9 into 3 27, plus 3 into 2 6. So it become 33 and upon 2, and this is power 1 by 2 minus 1 by 2. So 27 plus 9 36, and it would be in the denominator. So root of 36 is 6. So it is going to be this. Let's cancel by 3 11 times and 3 2 times. It become 11 over 4. So now we have the gradient of the tangent. The gradient of this tangent is 11 by 4. So gradient of normal at P is going to be minus 1 over 11 by 4, that is minus 4 over 11, because they are perpendicular, so it would be negative reciprocal, and hence now we can find the equation of normal. Equation of normal will be y minus y1. Y minus y1 is y minus 6 is equal to minus 4 over 11 times x minus x1, that is 3. So we will simplify, we will get y is equal to minus 4x over 11 minus 4 and minus plus, sorry, 4 3 is 12 over 11 minus plus 6 here. So we got y is equal to this 11 6 66 plus 2 68 plus 10 78. So minus 4x over 11 plus 78 over 11, though it was not required because we only need to find the y coordinate, so we only need to have this value as 0, with x value will be 0. So at or on y axis x will be 0, and hence this y coordinates of this normal where it intersect the y axis, it is going to be minus 4 into 0 over 11 plus 78 over 11. So it means y is equal to 78 over 11, or we can write in the mixed fraction. So 11 7 times 77 plus 1 over 11. This is the y coordinates of the point where it intersects with the y axis. Let's do the next part. The diagram shows the curve with equation y is equal to 4x to the power 1 by 2. The straight line with equation y is equal to x plus 3 intersects the curve at points A and B. So it's like that, it will intersect these two. Find the length of AB. So since they intersect for A and B, will equate these two curves. So for A and B, 4x to the power 1 by 2 is equal to x plus 3. It should be equal to this. Now we need to simplify this, solve this to get the value of x. So let's take the square of both the sides. We'll get 16x is equal to x plus 3 whole square, that is x square plus 6x plus 9, or we can rewrite it as x square. This will go that side, it is going to be minus 10x plus 9 is equal to 0. So we know the two numbers by which if we'll multiply we'll get 9 and add we'll get 10, it is 9 and 1. So it is going to be x minus 9 and x minus 1 directly we can write, or we can simplify, split the middle term. So from here we will get x is equal to 1 or x is equal to 9. So it is like at A x is equal to 1 and at B x is equal to 9. So corresponding y value we can get from either of these two equations. I'll get it by this. So y is equal to 1 plus 3, that is 4, and y is equal to 9 plus 3, that is 12. So coordinates of A is going to be 1 comma 4 and coordinates of B is going to be 9 comma 12. So these are the two values of these are the coordinates of A and B. So now we can easily find the length of AB. So AB is equal to square root of difference of the x coordinates and y coordinates. 9 minus 1 and 12 minus 4. So it is going to be 8 square 64 plus 12 minus 4, 8 square again 64, and hence it is going to be 8 root 2. So AB length is 8 root 2 unit. So I hope it is clear. Let's do the next part. Here's the second part. The tangent to the curve at T is parallel to AB. So the curve was like this, and suppose this is A and it is B. So T will be somewhere here. The tangent at this point, it is parallel to AB. So now we can see this T at and B coordinates 1 comma 4 and 9 comma 12. So we can find the gradient, and hence we'll find the this gradient will be equal to the gradient of this tangent, because these two are parallel. And for this t we'll find dy over dx from the function y. So let's find gradient of AB. It is 12 minus 4 over 9 minus 4, and it is 9 minus 1, it is 8 over 8, that is 1. So gradient at t, so gradient at this also it is 1. So now since y is equal to 4x to the power 1 by 2, and hence we can get dy over dx also, and that is 4 into 1 by 2 x to the power 1 by 2 minus 1, so that is minus 1 by 2. So it is going to be 2 over root x. We can write like that, 2 over root x. So now we have the gradient, and this gradient should be equal to 1 because it is parallel to this. So it means dy over dx is equal, should be 1, because this is parallel to AB, and we have the gradient of AB as 1. So 2 over root x should be equal to 1, or we can say x root x is equal to 2, and hence x is equal to 4 by taking the square. So x is equal to 4. Now we got x value as 4. This at this point x value as 4. So if x value is as 4, so we'll get y value as well. Y value is going to be 4 into 4 to the power 1 by 2, that is 4 to the power 4 into 2, it is 8. So it is 8. So coordinates of t is, so this implies t coordinate is going to be 4 comma 8. I hope it is okay. Let's do the next part of this question. Third part. Find the coordinates of the point of intersection of the normal to the curve at T with line AB. Normal to the curve at T with the line AB. So it's like AB is here, A, B, T is somewhere here, and if you'll draw a tangent and the normal to this, we need to find the coordinates of the point of intersection these two. So we know this gradient is 1, so this we can say, let's take this is n. So normal gradient of normal at t is going to be minus 1 upon 1, that is minus 1, because it is that gradient of this tangent at t is 1. So now we have the coordinates of t also, it is 4 comma 8. So equation, and t is 4 comma 8, so this implies equation of normal, because once we have the coordinate and the gradient, we can always find the equation of normal, that is y minus y1 is equal to gradient minus 1 times x minus x1, that is 4. So it is going to be y minus 8 is equal to minus x plus 4, or y is equal to minus x plus 12. So y is equal to minus x plus 12 is the equation number 1, equation of this normal, and equation of AB, equation of AB. A is 1 comma 4 and B is 9 comma 12. So equation of AB also we can find. It is going to be y minus y1, will take 4, is equal to gradient is 1 into x minus x1, x minus x1, that is 1, and hence it is y is equal to x plus 3. So this is equation number 2. We need to find the intersection of these two. So from 1 and 2 we have minus x plus 12 is equal to x plus 3. So we need to be very careful with this. First of all, we found the equation of this line, then, and then find the intersection by solving the simultaneous linear equation. Before that, if we have the gradient of the tangent, then we can find the gradient of normal. We have the coordinates of one point, that is t, where we are going to draw the normal, and hence we have the equation. So now from here we'll get 12 minus 3 is equal to x plus x, because I'm transferring this thing over there, so 2x. So x will be 12 minus 3, 9 over 2, 4.5. So if x is equal to 4.5, we can get y value from any of the equation 1 or 2. So this will give y is equal to, I'll take it from 2, x plus 3, that is 4.5 plus 3, it is 7.5. So this coordinates of intersection point is going to be 4.5 comma 7.5. So this is this was the last question of this paper. I hope it was understandable. So thank you for watching. Thank you so much.